Welcome to a short overview of the program Prognoz. It serves for predicting of numeral perspective areas using any rasters and standard points. Let's load the raster dataset. Test data. On the right side we can see a main plot of points and rasters. We can toggle display of points and or labels separately. Also we can show pixels, borders and labels abbreviations table like that. We could resize the view, change the color bar, and restore to default. In the current dataset, there are two areas with two similar kinds of rasters, magnetic and gravity fields. Each area has point features with deposits classes and background standards. Background, deposits classes. The program will extract rasters values at points for each area and create a summary table, which will be used for model fitting. We can create a model right now or perform a unique program feature, value decomposition. We should select any rasters to decompose. Let's select all. Let's also increase the size of the rolling window to 5. The remaining settings can be used by default. It is possible to apply decomposition multiple times at different settings. New derivative rasters will be created. Here we got our new derivatives. We could export them if necessary with that button. The program will create adjectives. Let's create a predicting model. We can select variables manually, holding a Ctrl key, or we can resort to a semi-automatic feature selection. The rest of the settings do not need to be presented. Both windows are connected. Here we have a list of variables. You can remove variables manually. All methods on the right. In any case, we can restore the list and start over. Let us exclude highly correlated features. There are quite a lot of after value decomposition. 8 from 22 are left. If there are a lot of features left, for instance more than 30, we better use invariant statistics to decrease the size. Let's click App Selection button. The right axis shows p-values. But also we can look at the scores table. P-values, names. That way we could select or exclude unnecessary variables. Let us exclude unnecessary. Here we go. Then we could perform RFE selection. It is a long process, so use it with care. I normally reduce the number of variables to 30, but here we got 7, so it's okay. The time, but anyway it took several seconds. In that graph, we normally should see a steep rise of accuracy, like that, and then a plateau. But here, in that current dataset, we don't have enough unique initial variables. Therefore, let's select the number of variables just to cover both magnetic and gravity fields. We don't have exact number in this current case, so maybe we can use app selection. It's a judgment call of an explorer. Select, and we see them selected here. If we lose selection, we can make it again. Select, create predicting model. Okay. Alright, the program shows us that both models are overfitted, but they still got high accuracy over test subset. We can try to reduce the number of selected variables to prevent the overfitting. Let's have a look at the matrices. True label, predicted label, by rows, by calls. So this one current dataset shows us that every pixel that will be classified as a gold deposit by MPL by SVC model, only 31% of them will be truly gold, and for MPL it will be 22%. It also shows us that only 29% of gold deposits will be classified as gold deposits by MPL and only 15 by SVC. So even here, MPL works better. Okay, let us apply a model. Apply advanced. You can choose any number of areas and select models. That is the plot of probability of a selected class, porphyr in that case. We can see anomalous areas, like that one, these. They could be outlined as perspective errors. To be more precise, we better look at a special plot, dependence of threshold probability with area and deposits. This is for porphyr deposits, but we can make it this way. That plot shows us the current predicted model could reduce the initial area to 3.3% by cost of losing 86% of deposits. This is by test subset. The train subset shows even less loss of deposits, but that gap shows us overfitting. We can use a different model. Finally, we can export one or multiple prediction plots to GIFs, like that. Note that prediction plots are not correlated, because each pixel should be classified as one of the class. If you have overprinted styles of mineralization, results will be different from ideal. Pay attention to your data.